Here we have a motherboard that I never worked on before. I do not even know what that board is. Customer mailed over this board labeled as good board, and he also mailed a donor board, which is a good thing. And this board is mailed, and this board is labeled as donor board. Now, if the customer was to mail one board only and he's asking us to fix it, I would have probably sent this board back to the customer unfixed, because I never worked on that board. I do not know what that board is, and we do not have parts for that board. So the fact that the customer mailed a donor board, that's a smart move, and it's more likely that we're gonna fix the board by having a donor board. Let's read what the customer wrote. I'm reaching out because I have a board that has a missing SMT connector that was ripped off, and most of the pads were also ripped. I did not do this personally. I bought these as parts boards. These boards are from an Anritsu MS2721B portable spectrum analyzer. So it's a spectrum analyzer device. I also have a donor board which has an undamaged connector. I would like to send in the board with the missing connector to be repaired using the donor board for parts. If it's possible to restore the pads enough to place the connector from the donor board, this would restore the functionality of the unit. I have tested the board with the missing connector and it's functional. I have been a fan of your YouTube channel for some time and really enjoy watching the rework you do. I also do SMT to fix units, but I have too many other repairs to do and would rather leave the pad strip restoral to an expert in that technique. Thank you, Kevin. So right now we do not know what type of Hiroshima we're gonna find on the board. The customer said that there's a ripped SMT connector with missing pads. So on the board we have a label that reads connector with an arrow. Let's follow the arrow and see what type of Hiroshima we're gonna find on the board, and if we are in fact going to work on this board or not. How many missing pads do we have? How big are the pads? A lot of questions. And if you look here, whoa. All I can say is whoa. And what is this? We have how many missing pads? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 missing pads. Are you kidding me? The last time I worked on an Xbox Series X motherboard with missing 19 pads, I thought I was crazy to work on such a board. And this one has 24 missing pads. What should we do? We're gonna charge the customer $100 per missing pad. What do you think? The Spectrum Analyzer, let's see how much that Spectrum Analyzer is and if it's worth it to work on it. If that Spectrum Analyzer is $300, $400, $500, then we're not gonna work on it because it's not gonna be worth it. We're gonna end up charging the customer more to fix it than to buy a used one. So how much is this Spectrum Analyzer? I'm not gonna spend time to restore 24 pads if we're not charging the customer a lot of money. So used, it's going between $2,400 to $4,000 used. I do not know if you can even buy this one new, but I do see the MS2721T $16,000 used. I do not know the difference between both. I do not work with Spectrum Analyzers. Anyway, it's worth fixing the board. If we charge the customer 1/5 of what it would cost to buy it used, then it's worth it. Let's start by grinding all the traces that we're gonna restore. And we're gonna start with this one. That's a very fine trace. And we're gonna be using version 2 of the grinding pen, the 0.6 bit. Very fine bit. It's really unpractical or impossible to scratch the mask with a tweezer. Let's try it. The grinding pen is honestly magic. I mean, if I am to scrape a trace with my tweezer, just look at how difficult that would be. Very unpractical. Those traces are extremely fine. So we know that this end is ground. This looks like a broken via. This here. Let's measure in diode mode. Yeah. So we're gonna have to solder this to that tiny little trace right here. And ground goes on the bottom. Those traces are extremely tiny. Actually, one of the smallest I've worked on. And when you have a trace that is so small, there's a limit on how much solder it can hold. I mean, just look at the clarity and the quality of the NorthridgeFix V2 microscope. If you are new to the channel, we carry and sell this microscope. We just came out with a bigger sensor than version 1, and this sensor is better than ever. I love it. If you have not purchased anything from us in the past, you can log in to NorthridgeFix.com, click on shop, and you can buy all your tools from there. We carry everything: hot air stations, soldering stations, power supply, grinding pen, flux, pad strips, microscope. Just add whatever you want to the shopping cart, check out, and almost always we ship out packages same day. I mean, look at this massacre. Look at this massacre. War zone. What can you do? No other way. Right now we need to align them as best as we can, and then I'm gonna apply UV mask so we can hold them in place. And then part 2 would be to remove the connector of the donor board, and part 3 would be to solder the connector on this board. I'm gonna try to do everything right now, and let's see how it goes. Now the hard part is actually cleaning the flux and all that stuff, because UV mask is not gonna stick properly on the board if the board has flux on it or it's not clean. We're gonna clean as much as we can. It's not gonna be perfect, but as much as we can. Let's start by cleaning, and then we're gonna apply UV mask, and then we're gonna have to tin those pad strips, then remove the connector from the donor and then solder it here. If that device was not expensive, I would not have worked on it, because the customer is gonna be charged a lot of money. And the other reason why I'm working on this is because the customer mailed over a donor board. If it wasn't for the donor board, then this would go back to the customer unfixed, because where else am I gonna get a connector? I do not even know how that connector looks like. Let me take a look. We're gonna have to go over the pins one by one. I'm gonna wrap an ear swab with a lint-free napkin, and I'm gonna tap like this, and all the wires are gonna shift and move, but we're gonna have to fix them again. Life is not easy. So we took all the flux off the board, or most of the flux, and you can see it on the lint-free napkin. But we're still gonna go over it. Let me switch to another side of the napkin and do it again. I mean, it does not matter how much I clean, you're gonna still see it under this microscope, under this V2 microscope, because it shows everything. Everything is so detailed. There's no hiding or running away. Okay, I think that's enough, unless we want to rip those pads off the board and redo it. And no thank you, I do not want to do that. So we're gonna have to live with what we see. The board is clean for the most part. What bothered me the most while doing this job are those capacitors. They are too long, too big. So I'm trying to hold the pad strip and my tweezer is touching the cap because it's too high. So I end up rotating the board, working on it from here, or doing this, or doing that. And that was the hardest part of working on this board. Those three caps, three big caps. And look at the mess that we just did. Look at the mess. So far, so good. And this one here is connecting the top to the bottom, because we have a line going all the way to the pad and another line going all the way to this component. So we are good. And we have to make sure that the one next to it is not touching this one. And we're done. That's it. We're gonna invoice the customer and mail this board back to him. Right? Not yet. Not yet. We still have a lot of work. Patience. Tranquilo, my friends. Patience is a virtue. I mean, I want to be done with this as much as you do. I'm sure you want to see the end result. Or maybe you're enjoying the struggle. I don't know. Let's apply UV mask here. And we're going to apply UV mask here. And here. Now it's time to put your shades on because you're going to be exposed to 10 watt UV light. All new viewers would really think that I'm serious. Old viewers would know what I'm talking about. The shades port. Because we had one viewer that wrote in the comments for all new viewers on the channel. We had one viewer that wrote in the comments, why are you exposing us to UV light? Like when I'm shining UV to cure the UV mask, or when I do this, then UV is going to penetrate your monitor, your screen, and then it's going to expose you to UV light. That's what the story is all about. Go figure. And I want to go over it one more time. The UV lamp will shut off by itself in about 20 seconds. So I did it twice. We have a lot of UV masks, so I want to make sure that UV hardens. And the UV light is off. You can take your shades off. I'm kidding. I accidentally exposed you to UV and made you take your shades off. Okay, let's take a look. I just want to apply a little bit of heat on this area. Now we're done. And I think everything is as it should be. No issues at all. Very nice. Are all the lines solid? This we can leave it loose because we're going to solder it to the pin of the connector. And this one is not solid. Maybe we did not clean the area very well on this side, and UV mask did not make a connection. What can you do? That's what happens when you do not clean the board very good. But we had no choice. If we want to give the board very good cleaning, then we're going to end up ripping all those pads again. And those pads are connecting to microscopic traces. You won't believe how tiny those traces are until you work on them. I mean, I would call this a Mission Impossible job, a miracle job. Okay, and let's wait. I applied UV light. Good, solid, solid. And I think we are all solid everywhere. And let's do it. See, it's a lot easier to tin a pad strip compared to a wire. Alright, so all the pads are tinned. All the pad strips are tinned. And all the wires are tinned. Just want to make sure that all the wires are making a good connection from the far ends. From here. Very good on this side. Connecting right here. And this one is connecting right here. That's no connect, connecting. And this one is connecting from this side and not from the bottom. And same thing with this one. This one's connecting from the bottom, and we're all good. We're all good. Very nice. We can keep the flux that we have on the board now because we're gonna have to solder the connector. Let's put that board on the side and look at the donor board and see how we're going to remove that connector safely and without damage. How are we going to remove that connector? Should we apply heat from the bottom? What's on the bottom? It looks like we have a big plate on the bottom. Can we remove this? Oh yeah. We can remove it. And we can most likely apply heat from the bottom to remove the connector. We cannot apply hot air from the front because two reasons. Reason number one, we're gonna burn that connector, and reason number two, we have aluminum capacitors. They're gonna pop if we expose them to a lot of heat. Option number three is low melt solder. We can remove this connector using low melt solder. We apply low melt on all the pins, top and bottom, and we should be able to take it out. But we're gonna have to do a lot of cleaning for low melt, so we do not keep any low melt on the pins. So let's try option one and see. The board is thick. I do not know how much heat it will take to be able to remove that connector if we are applying heat from the bottom, but we're gonna try it. Temperature on max, 500 degrees Celsius, and airspeed on max. I'm also going to apply flux because flux helps with the flow of solder. So let's apply flux. Okay, got it. Got it. I just put my goggles on in case one of those aluminum caps pops, even though I'm applying heat from the bottom. But what if? My eyes are more important than a motherboard. Let's put this one on this side, and let's grab the board that we worked on. And this one we do not have to apply any hot air. We're gonna do it manually if we can. If you look here, we do not have any supporting legs for that connector to secure it and hold it down in place. So all the pins of the connector will make a connection with the board via those pads. We're gonna start by soldering those pads here, the ones that are solid, so we can secure the connector on the board, and then we can go over all the pins. The connector is intact, excellent condition, and that's because we applied heat from the bottom. I'm gonna press it down with my finger. And do not look at my finger, because when you look at your finger under a microscope, you're gonna find wonders. You're gonna find dust, debris, hair, elephants, giraffes, flies, bugs, crickets, everything. Okay, so we secured the connector with those two pins. Now we're gonna do the same from the other side. And look at how beautiful this cap is. It's just sitting there, laying around, relaxing, having coffee, and not giving any care about what we are doing here. Okay, we're gonna have to apply flux, because without flux, solder is not gonna flow properly. Look at how every wire is aligning perfectly with the connector pins. That's amazing. We really did an awesome job with this. Yeah, look at this. I cannot even push the connector with my tweezer because of the long capacitors. Tweezer is touching the capacitor, so I have to go at an angle, and I do not want to puncture that connector. Let me do it with maybe something like this. No, that's a bad idea. Rotate the board and do it that way. Very nice. So far, so good. Very nice. Very nice. Awesome. We did an amazing job. Amazing. We're gonna go over the pins and make sure they are making a good connection with the pad strips and the wires that we ran. But let's finish with, oh, you know what? Let's go over this side first, and then we'll finish side number 2. So the first 2 are gonna be good because they are solid pads. And this one here, look at this, it's moving with the wire, that's good. And this one is good. Very nice. It's moving with the line. This one is solid. And this one is moving with the line. Moving with the pad strip. Very nice. Moving with the wire or the pad strip. We only ran 2 wires here, and the rest are pad strips. So this side is amazing. Absolutely amazing. Let's do side number 2. And it's gonna be harder to get the soldering iron in here because, like I said, those long caps, look at how big they are. And we have one here. So we're gonna have to work on this side at this orientation, like that. Awkward, but what can you do? Look at this, the soldering iron is touching the cap, you see? We're gonna have to go vertically, if possible, like this. Press down, very nice. Oh, that's amazing, actually. All we have to do is press down. We already tinned the wires with solder, so as soon as we apply heat on that pin, solder on the wire will liquefy and make a connection. Now this one is loose from this end, which is fine because it's making a connection from the other end. And that's gonna connect. And finally, we have this here. Awesome. Now, this side has to pass the solid test. Solid. Solid. And is this one making a connection or no? Let's go over it one more time. And I'm gonna add some solder on my soldering iron tip. Okay, now that's good. Solid, solid, solid. Very nice. And this one is not supposed to make a connection from the bottom. It's making a connection from the top. And the pin is moving along with the pad, which is making a connection all the way here. That's good. And same with this one. Awesome. This one is not making a connection with anything. It's a no connect. And this one is solid. And this one is solid. Making a connection from the inside and not from the outside. And this one is making a connection from the inside as well. Just making sure. And this one, we may have to go over it. And let's check now. And very nice. The pin is making a connection with the wire. Same here. Solid. And this one is a no connect. Amazing. Done. Wow. Let's clean up. I went over every single one and all of them are making a solid connection. Now if the customer plugs this in and it does not work, too bad. We did what we had to do. We're not going to troubleshoot anything else on the board because we have no experience troubleshooting or working on such board. But you fix everything. Can't you fix this one if it has a problem? Well, yeah, if I want to spend the time. If I want to spend the time to learn how that circuit board works and I have nothing else to do, then yes, maybe. How much are you charging the customer? A lot. Whenever you ask the question, how much am I charging, when there's a lot of work involved, it's a lot. I do not want to say how much because people, for example, from India, they're gonna faint. Oh, we can get this fixed in the shop next door for $2, for $1. That's the response that you're gonna get. Just multiply that $1 by 500-600 and that's what we will be charging for this repair. That's USA. India, it's $2. Pakistan is $2. Philippines, maybe $3. But in the US, it's different. Do not compare the rates in the US to rates in India. I pay $6,000 for the shop rent, and that's the shop alone, not counting electricity or water or garbage or sewer, insurance, and 101 things that we pay here to make this business run. And that's not counting all the fees that we have to pay for the government. License fees, sales tax, business tax. We had a person that came into the shop from the government, and that was about maybe 2 years ago. He came in with a badge. I said, how can I help you? And he said, do you have a bear license? So I was scratching my head. What's a bear license? I've been in business for 8 years and nobody ever asked me for a bear license. What's a bear license? I never heard of it. And he took out his book and he wanted to write a citation, a ticket for not having a bear license. What is a bear license? What does it do? He said, if you fix electronics, you need to have that license. Okay, no problem. I'll get one. He said, no, I have to write you a ticket. I said, hold on, I do not know what a bear license is, and I will be more than happy to fill out the application right now. So he made me fill out the application. He was a nice person, and we had to pay the government like $100 for that license, just to have it in the shop. You do not have to study for that license. You do not have to take a course for that license. Anybody that opens a shop fixing electronics, he can just fill out his name, address, whatever, and then he can get that license. What is that license for? Is it some type of qualification that qualifies me as a person who can fix? No. So what is it? It's just a paper from the government, so we can make you pay that $100. $100 is nothing, for that license, but just imagine how much money they are making from every business $100 each, and that's how the government makes money. But at the same time, the government here in the US, they also give. During COVID, they gave us money. Every single person in the US got money, and every kid in the US got money. Schools, the roads, cleaning, garbage. So the government does spend a lot of money. They take a lot of money from us, but also they spend a lot of money. So we cannot really complain. They take from one end and they give you from the other end. Is it equal what they take and what they gave? I don't know, but at least they gave. They do not take and not give. They do give back. The government does give back. And that's it. We're gonna end the video right here. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.